I have the absolute value of 2x minus 7 is less than 13. So visualizing this on a number line, here's 13. It doesn't equal 13, but it needs to be less than 13. The answer does. But because it's an inequality, I recognize that any answer that's negative but also in that range, say -4, as an absolute value would be a +4 and would also be in my solution set. Therefore, I need to set up two inequalities. 2x minus 7 is less than 13, and 2x minus 7 is going to be greater than a -13. Now I will solve both inequalities. Add 7 to both sides. 2x is less than 20. Divide by 2. X is less than 10. Add 7 to both sides. 2x is greater than a -6. Divide by 2. X is greater than a -3. And as I look at these answers on a number line, I have 10 and a -3. I want x's to be less than 10, but I also want x's to be greater than a -3. So that's where I have my x's are in between a -3 and 10. I have 2x plus 3. The absolute value of that is less than 8. Well, if it's less than 8, it means it doesn't equal 8, but it's anything less than 8. However, it's an absolute value, so that also means that a -8 doesn't equal it, but it's also in that range of -8s. For example, you could look at 4 as a solution, or -4 in that range. But what is this 2x plus 3? So, 2x plus 3 is less than 8, and 2x plus 3 is greater than a -8. Solving this, I have 2x is less than 5. Divide by 2 on both sides. X is less than 5/2. 5/2 would also be 2 1/2. Subtracting 3 from both sides, I have 2x is greater than -11. Divide by 2. X is greater than a -11/2. -11/2 would also be a -5 1/2. Again, this was an and situation. So what we're looking at is x's are between these two numbers. So starting at -5 1/2 and going to 2 1/2. That's my solution.